Okay, here's another cool demo for you. Hopefully you've seen this one before or heard of it. I found that most students have. This one's called the elephant toothpaste demo. You've probably seen it, all sorts of craziness on YouTube and stuff. I think I shared a cool video with it already, but I wanted to show you it from a how do we change reaction rates perspective. So obviously it's a cool reaction. If you haven't seen it before, you take hydrogen peroxide, a little bit of dish soap, and a little bit of food coloring just for fun. And then you add a catalyst. You can add a catalyst. The catalyst for this reaction is called potassium iodine. And all it does is it speeds up the reaction. What's happening in there right now actually is a hydrogen peroxide, which we use for cuts, is breaking down. It is bubbling a little bit into a gas and water and hydrogen gas. But this catalyst will make that happen much faster. So that's the first thing that we can do to speed it up. Now, in this first tube, we have what I would consider normal grade hydrogen peroxide, like 5 to 10%. You can go out to Walmart and buy this hydrogen peroxide. A little bit harder to get your hands on potassium iodine, but that's okay. I have plenty for all of us. So let's see what happens when we add the potassium iodide to the hydrogen peroxide. Goes in, and it bubbles. There's also steam that comes off the top here. I know that's a little bit harder to see on the camera, but it is steaming. If you're in class, I'd actually let you come in. It stains the skin a little bit yellow for a day, but it's still kind of cool usually to touch warm bubbles. It's kind of fun to play around with. And it just kind of keeps going for a while. In fact, if I let this sit here, it would just keep reacting like this until one of the two things, until the hydrogen peroxide ran out, or the bubbles ran out of soap, basically. Those would be your options for when this will actually stop. But hopefully you get the sense that this isn't the cool, explosive, like hit the ceiling reaction that you see all over the place on YouTube or anything like that. Some of the videos I shared where it's flying all over the place. Two things going on there. First, I picked a very large beaker, so there's not a whole lot of pressure that can build up over this large surface area. I did that because I don't want the ceiling stained. I don't want to replace ceiling tiles. Our custodians wouldn't be happy with me. And second, the thing that's going on is that usually they don't use store-bought Walmart potassium or hydrogen peroxide for their experiments. So let's move over one lab bench here. In my second beaker here, kind of looks the same. It's the same amount of liquid, just a different color. And this time, I have 30% hydrogen peroxide. This is the stuff you need to be a scientist to get your hands on. Really need to, not something you can typically get. And that means I increased my concentration of hydrogen peroxide. In addition to that, I'm increasing the surface area of my potassium iodine by crushing it up a little bit more. So I'm increasing surface area and I'm increasing concentration, both at the same time, while adding a catalyst. About the only thing I could do to make this go faster is I could preheat it, which I've seen people do, and that's usually how they do it on YouTube to get it going really good. And I could maybe stir it too. So you could get a stir rod or something in there. We'll see if this is impressive enough just with increasing concentration. So here we go, potassium iodine into 30% hydrogen peroxide. And I would say that's impressive enough for my liking. I might still have a mess going on here. So there you go. All I did was I increased the concentration of hydrogen peroxide. You can see the steam coming off. This thing is still going crazy. It's going to keep going, like I said, until the hydrogen peroxide runs out or until the soap bubbles run out. It just keeps going and going and going. And that's with only doing one thing. I didn't do any of those other factors. Imagine if I did all of the different factors at the same time, how cool of a reaction we could have. We could have this up to the ceiling in a hurry. So there's your factors affecting rate of reaction demonstration.